Welcome back to our lecture series on automated machine learning. We are still talking about the motivation, and here I would like to give you some more ideas on the success of automated machine learning, what it achieved over the years. There are many of these. I can't cover all of them, but to give you an intuition into that at least. So a lot of things started actually with the so-called automatic machine learning challenge, which was then summarized and was closed in 2019, but I can't remember fully anymore, but I think it started 2015 already, the first edition of that. And it was the first full automatic AutoML competition, which means that when we participated back then, we uploaded our code, our AutoML system, and we were seeing more or less on different kind of data sets. It was doing the evaluation automatically, and we saw the public leaderboard on that. And later on, after was the deadline, we only then the real data sets for the competition were evaluated given our code base, our AutoML system. And then there was more the final leaderboard based on that. And we had no way to interact with our system at that point anymore, right? This was only the code submission, had limited resources, which of course we were roughly aware of that, but there was no human intervention anymore. And the very first edition, very first phase of that had even human teams still being included. But later on, it was only AutoML system. But even then, AutoML systems showed already a reasonably good performance back then. In these kind of competitions, quite a success to how to do automated machine learning was combining Bayesian optimization on fairly full pipeline, starting from pre-processing to the model, to also at the end, the ensembling, and then being in a very efficient way, for example, combining that with multifidelity optimization. Also in 2019, there was a very big hype, and we have seen that, for example, on the Gartner hype cycle. It's very tiny here on the slide, but here it's written automated machine learning. It was really on the peak of what's called inflated expectation. Many people were talking about that. Google were, for example, launching several AutoML services, and other companies too. And one of the reasons was that the year before, automated machine learning showed for the very first time that neural architecture search as a part of AutoML can find better neural networks, computer vision tasks than humans could find before. So really achieving new state-of-the-art performance and more or less a fully automated fashion. And that showed a promise. Many people were excited about that. There was a lot of hype on that topic. But we also had to admit in 2019, we have not really understood back then what it really means to run AutoML in a very productive setting, really in companies and so on. Therefore, I fully agree with that. It was some kind of inflated expectations. But the nice thing is now, 6-7 years later, we know that much more better and have much better insights by now. Then there was 1 year later a competition at NeurIPS. NeurIPS, one of the biggest AI machine learning conferences which are on the international stage. And that was really running black box problems for machine learning. So more or less pipeline optimization most of the time. And the point was showing in a very convincing way that what people used so far, which was grid search and random search, is not state-of-the-art, but more advanced technologies, something like Bayesian optimization and combinations of several other techniques can actually perform much better, that you're getting much better results in a shorter amount of time, and that you can really do that on a diverse set of benchmarks even. Nevertheless, although grid search random search were convincingly outperformed, there was no clear single best approach to that. And it can also a bit depend on that setting, what you need as optimization. One of my personal experiences was also quite nice, was also 2020, when I started in Hanover and told everyone here I'm doing automated machine learning. And there were people coming to me and asking, okay, Marius, show me how good you can do. And they gave me actually a digital twin project for milling processes. This was all about producing these kind of metal pieces over here. There was a PhD student from another lab sitting down, collecting a lot of data on that milling process, and then giving me the data. I was saying, come on, Miles, show me that you can be better than what I achieved. And what we can see here now was the result on the right side, that arm is E on the y-axis, so lower value is of course better. And we have time on the x-axis. And each of these dots here is one model, one machine learning model. You're seeing that the system is trying out several of these. And if you wonder why that we are a bit more sparse here and then getting denser and denser, actually is because here we are on a log scale on X. That's to be expected. The nice thing is why that was such a cool experiment, and that's then also to a publication, was that the student spent, so PhD student from the other department, spent roughly 3 months on finding a very good model and got stuck and at RMSE of 0.05. And automated machine learning, one of the approaches we developed beforehand, pressing the button, waiting, was finding a better solution, slightly better solution, or if after 27 seconds, where the PhD student needed 3 months, and was improved by another factor of 5 on RMSE within roughly an hour. That shows the potential. Me getting only data, pressing a button, getting a very decent model, having a publication. Industry partner was very happy about that because now they had much better digital twins. There was also then another very big AutoML competition, the AutoML Grand Prix in 2024. It happened on Kaggle, this very famous data science machine learning competition platform. Each month there was one new task that was going over 5 months. And only very first 24 hours, AutoML systems were able to participate, and the humans were running actually for a longer time. The winner of each competition got 25 points, also among human teams. The best AutoML system got, no less, 73 points out of 125 points. I think that's a very good number. The winner was Light AutoML system. The bit unfortunate part of that, although it showed that AutoML systems are very strong, very competitive to many humans, and there was no way to cheat around it because really AutoML had 24 hours, humans much more time. But it turned out data processing was quite important, which is maybe not a surprise for people already doing machine learning for quite some time. If you're starting, of course, with clean data, everything's very nice, easy to do. But the moment data gets messy, of course, you first have to fix your data before everything else. Then 2025, sorry, there was the start of a new big hype coming around the corner, which was foundation models. For example, tabular foundation models. Here, a Nature paper on the left side shown on the system called TAP PFN. Still one of the state-of-the-art systems for tabular foundation models. And the nice thing is, it was more giving you the option, or still giving you the option to do machine learning out of the box without any training, without any optimization ends whatsoever. Because what's the main idea of a foundation model is you invest once a lot of time into training one very big model, surprise, surprise, on a transformer architecture. And then what you simply have to do is in-context learning. So what you're doing is, in context, you're feeding in your entire data set, including the training data set and your test points, and the tabular foundation model will return you the predictions on the test data points. So it's more as a dream of automation by having a simple load and predict action, allowing a frictionless execution for all kinds of tasks, at least in that kind of data modality, tabular data. But by now there are also tabular there are foundation models for time series. There are foundation models for, of course, text. The large language model is nothing else than that. So it is getting more and more traction in that direction. Automated machine learning is also actively used. So I found one reference. I Unfortunately, I have to admit, I was not able to verify all of these, but I gave you the link also in here directly. And they're saying, okay, several companies actually using by now automated machine learning. That's only a small part of it. They're using different kind of tools, of course, with different kind of industry, from real estate, finance, consumer goods, technology, insurance, and so on, different kind of use cases. And that all of these can use more or less a few AutoML tools shows the power actually and how well automated machine learning is by now established into the industry context. The automated machine learning community was also growing over the years. By now, the automated machine learning community has its own annual international conferences, which you can find at automl.cc. There's a monthly AutoML seminar. You can find actually, there's a podcast you can find on all these kind of streaming platforms. There are many different kind of packages. AutoGluon I mentioned before. Optuna is also a very famous one. You can find an overview on automl.space. There's of course the MOOC you are right now listening to, and there are many, many more things. With that, I hope I have convinced you that there are many success stories for automated machine learning. What I haven't mentioned so far is that AutoML ideas actually go back quite some time to the 70s with algorithm selection, or with 90s with neural evolution. I believe personally that the main breakthroughs nevertheless started around 2012 to 2015 as an implicit consequence of the deep learning hype, because more and more people wanted to use deep learning, machine learning, whatever you would like to call it, and get better out of it. And it was pretty, it is still pretty, you have to think about certain kind of things if you'd like to apply it to new awesome applications, and automated machine learning can help you with that. So the moment people get more and more interested in these kind of deep learning, machine learning technology, they also got more and more interested into automated machine learning. And I showed you some impressive results on many domains. Nevertheless, I should also say, I think the most impressive results, which is a bit biased by the community, is still on tabular data, although I mentioned before, for example, that also automated machine learning, in particular neural architecture search, found several times state-of-the-art architectures for computer vision tasks. AutoML can perform as well as top human teams in predefined settings, of course. It's not like humans can be fully replaced, but augmented and supported by that, and that you can get much more efficient. And as I showed you, it is used by many companies. With that, I hope you have a bit of overview and what AutoML achieved over the years, and I hope to see you in the upcoming videos.